material session of a pulsar's career point. This is a video for the student of class 12 on unit 8. The first chapter of this unit is Aldehydes and Ketones. This is the 9th video of this chapter covering the topics that is chemical properties of aldehyde ketone, reactivity of aldehydes and ketones, how reactive aldehydes and ketones are towards the nucleophile. Reactivity of aldehydes and ketones. The carbonyl group in both aldehyde and ketone is a highly reactive polar group, as the pi electron of them is shifted to the more electronegative oxygen atom, as a result of which oxygen acquires a partial negative charge and the carbonyl carbon acquires a partial positive charge in the same way as shown in the diagram. As the electronegative oxygen is more than carbon, the pi bond is shifted more towards oxygen atom and it acquires a partial negative charge, while the carbonyl carbon acquires a partial positive charge. Thus, the carbonyl group is two active centers which can be easily attacked. The positively charged carbon atom is readily attacked by electron-rich nucleophiles. The negatively charged oxygen atom is attacked by electron-deficient electrophile. However, during addition reaction, the nucleophilic attack precedes the electrophilic attack because anions produces is more stable than the cation. So first of all, the nucleophile will attack. So how the reaction is carried out? The nucleophile is negatively charged. It will attack the carbonyl carbon from the back side. And after that, electrophile will attack to the negatively charged oxygen atom and will get corresponding nucleophilic addition. Order of reactivity of aldehydes and ketones. Due to inductive effect and steric effect, aldehydes are more reactive than ketones. The order of reactivity will be formaldehyde is more reactive than aldehyde is more reactive than ketone. Now, why? Due to inductive effect. In case of formaldehyde, there is no plus I group at all. The carbon is attached to two hydrogen atoms which have almost same electronegativity with carbon. But in case of aldehyde, general aldehyde, the carbon is attached to one plus I alkyl group, which donates electron to the carbon and partially compensates the deficiency of electron of carbonyl carbon. So the reactivity slightly decreases than formaldehyde. But in case of ketone, the carbonyl carbon is attached by two electron donating plus I alkyl group, which further compensate the deficiency of electron of the carbonyl carbon. As a result, the backside attacking of the nucleophile gradually decreases. So what we have to write down in plus I? Alkyl groups are electron releasing plus I group. The presence of alkyl group at the carbonyl carbon decreases the magnitude of positive charge over the carbon atom, thereby decreasing its tendency to accept the nucleophile. Hence, the reactivity decreases from formaldehyde to ketone with increase in number of plus I group. Very shortly, we can write down from formaldehyde to ketone, the number of plus I group gradually increases, which decreases the magnitude of positive charge on the carbonyl carbon. Hence, the reactivity decreases. In shortcut, we can write this also. Now, minus I effect. The presence of electron withdrawing group at the carbonyl carbon increases the magnitude of positive charge over the carbon atom, thereby facilitating the nucleophilic attack. Thus, the reactivity order of substituted acetaldehyde will be as follows. Nitroacetaldehyde is more reactive, then chloroacetaldehyde is more reactive than acetaldehyde. Size of alkyl group. With increase in the size of alkyl group, the reactivity decreases. Thus, the order of reactivity of various ketones are as follows. Acetone is more reactive than ethyl methyl ketone, is more reactive than dimethyl ketone. As the alkyl group, size of alkyl group increases, then the reactivity goes on decreasing. Now, steric effect. How does steric effect play a role on the reactivity series? The approach of nucleophile is prevented by the presence of bulky alkyl group at the carbonyl carbon. This effect is known as steric effect. The attack of the nucleophile at the carbonyl carbon becomes more and more difficult as the number and the size of the alkyl group increases. Hence, the reactivity of aldehydes and ketones follows the following order. Formaldehyde is more reactive than acetaldehyde, is more reactive than acetone, is more reactive than ethyl methyl ketone, is more reactive than diethyl ketone. Thanks for watching Bhopal Search Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updatation of my new video.